Alright, so for Algebra 2 8-1 inverse variation, our learning objective is to recognize and use inverse variation and to use joint and other variations. Our essential understanding, and if you look under the section in the book, it's a lot longer, but I think the second half of it breaks it down the best. Inverse variation is when two quantities vary inversely, which means one value increases while the other value decreases proportionally. So the beauty is the proportionally. If it's not proportional, then we can't calculate it. Alright, so let's see how this looks in application. We're going to do the example where we take a look at a little XY table and decide is the relationship direct, inverse, or neither. And we're going to write the function. So for our first item, the XY table is 0.2, 8, 0.5, and 20. 1.0 and 40, 1.5 and 60. To tell if it's an inverse variation, but I'm going to do that first because it's the easiest and I'm a fan of easy. If I multiply x times y and I get a constant each time, then it's an inverse variation. Before we do that, I want you guys to write this under inverse variation because it looks three different ways. So you may have an inverse variation that's x times y equals k. And remember, k is our constant. It could look like, if I divided both sides by x, it could look like k over x. Or if I divided both sides by y, it could be x equals k over y. So what we're doing is we're testing for inverse variation. If I multiply x and y together and I get the same constant each time, then it's inverse variation. So let's try that. So I'm going to pull up my calculator so you know I'm not making up numbers. So if I have 8 times 0.2, I get 1.6. And then I'm going to go 0.5 times 20. And I get 10. Do I even need to continue testing for inverse variation? No, it's not a constant. Multiplying the x and the y together is not constant, so it is not inverse. So now I'm going to test for direct. And if you guys remember, testing for direct, we take our y value and divide it by the x value. So we're going to take 8 and divide it by 0.2. And I get 40. Then I'm going to take 20 and divide it by 0.5. And I'm going to get 40, so it's looking good. I'm going to take 40 divided by 1. Thank goodness I don't need a calculator for that. And then 60 divided by 1.5, my fingers are crossed that is going to be equal to 40. Yay! So in this case, we are a direct variation. So guys, what is our K value? Yeah, it's 40. So if we were going to model a situation, we were going to write the function, we would write y equals 40x. Yay! Okay, so let's try another example. We have our x, we have our y. So what if we had 0.2 and 40, 0.5 and 16, 1.0 and 8, 2.0 and 4.0. So I'm going to test for inverse first. Why do we test for inverse first? It's easier. It's multiplication. So let's test for inverse. So I'm going to go 40 times 0.2. Actually, know that one without a calculator. 8.0. 16 times 0.5. 8.0. 8.0 times 1.0. 8.0. And 4.0 times 2.0. 8.0. Yay! We found it. Okay, so then we're gonna model, and since our K value is 8, we're gonna go x times y equals 8. So if it's inverse, we have to use the inverse variation, which is different than the direct. And if you want me to put the direct, it's right here, direct. If you remember, direct variation is y equals k times x, and inverse variation is x times y equals 8, or y equals 8 over x. You guys can write it like that as well. All right, so here's how you might see this as well, and I wanted to make sure that you guys saw it with me first before you ran into it in your problems. If you're given a problem, suppose x and y vary inversely, and x is equal to 8 when y is equal to -7. We're going to find the function that models the inverse variation. We're going to find what the graph looks like, and we're going to find what is y when x equals 2. So the first thing, let's do A first. So let's get our shell. If x times y equals k, then we have x is 8, y is -7, so k must equal -56. So the function is x, y equals -56. Or, because if we're graphing, a lot of times we like things in terms of y and x, y equals -56 over x. So I'm going to do B down here. And on my graph, I'm going to put, I think I'm going to go in increments of 4. So let's go 4, 8, 12, 16, 20. Same with here, 4, 8, 12, 16. Same with here. So where our graph is increments of 4. So if I'm trying to plot points, if I plug in 0, well, I can't. Why can't we plug in 0? For x. X is going to equal 4, 8, 12, 16, 20 from this graphing. So it can equal anything. But I'm trying to get a shape. Why can't I put in 0 for x here? Can you divide by 0 ever? No. So 0 is not an option for us. So let's plug in, 1 is pretty easy, right? So if I put 1 in for x, so negative 56 divided by 1, negative 56, that's really, really negative. So on my graph, that would be like way down here. So let's plug in 4, negative 56 divided by 4 is negative 14. So here's negative 16, that's like right here. Let's plug in 8, negative 56 divided by 8. Negative 7. Let's plug in 12. Negative 56 divided by 12 is negative 4.6.
It's negative, shouldn't it? Going in the other direction.
Am I plugging in the numbers wrong?
I thought they were supposed to, if it's x equals negative 7, wouldn't it be going towards the left?
I'm not having x equals negative 7. We could do that this time. But I'm saying x is 1, positive 1. So that's on this side of the... So if x equals positive 1, y is equal to negative 56. That's right here. So I'm just putting in positive x's right now. That was negative 4.6, so that's like right here. When I put in 16, for x I get negative 3.5. It's like right here. When I put in 20, that's negative 2.8. That's right here. So this graph is going to look like there's a nice curve here, and then it starts approaching the x-axis. Then let's go on the negative side. If I divide 56 by negative 1, it's like positive 56. It's way up here. I divide negative 56 by negative 4. And I get 14. So it's going to be a nice mirror. I should make my increments a little bit more consistent. So it's going to come down and mirror what we have on the other side for negatives. So we have a nice asymptote at x equals 0. All right, C says, what is y when x is equal to 2? So in here we go y equals negative 56, and when x is equal to 2, half of 56, 27? So y is equal to negative 27 when x is equal to 2. All right, so we're going to talk about combined variations and how it looks equation-wise given the words. So if z, the variable z, varies jointly with x and y, then your equation looks like Z equals our constant of variation times X times Y. If Z varies jointly with X and Y and inversely with W, so Z equals constant of variation, X and Y on the top, and because W is the inversely part, W goes on the bottom. Now if we get all crazy and it says Z varies jointly with X and inversely with WY, so here's our Z, our constant of variations on the top, X is on the top because it varies with X, and inversely with WY. So we can start combining all of them together. All right, so our example problem that we're going to use combined variations is the number of bags of mulch you need to cover a planting area varies jointly with the area to be mulched, A, in square feet, and the depth of the mulch, D, in feet. If you need 10 bags to mulch 120 square feet to a depth of 3 inches, how many bags do you need to mulch 200 square feet to a depth of 4 inches? So if I'm going to take the first sentence, and I'm going to say that the number of bags is going to be B. The number of bags varies jointly, so I definitely need my constant, with the area to be mulched, A, and the depth of the mulch, D. So here's my little combined variation, B equals K times A times B. So the first thing I need to do is find K. And we have a little issue because if you look here, D needs to be in feet, but the depth they give us to find the K value is in inches. And all my chemistry students who thought, oh, we only have to do dimensional analysis in chemistry are saying, right, I'm going to use dimensional analysis. So if I were to put this in using 10 bags, you don't know what K is, that's what we're finding. 120 square feet. And the D value, it's 3 inches, but there are how many inches in 1 foot? 12. So my dimensional analysis says inches pencils with inches. 3 divided by 12. I would like it as a decimal point. It is 0.25, so we can say 0.25. All right, so we're going to solve for K. So K happens to equal 10 divided by 120 times 0.25. All that is a calculator chug-a-lug. So I'm going to get my calculator out. So 10 divided by 120 times 0.25. And I get 1.6 repeater. And in fact, I am going to convert that to a fraction because I don't want to write all those 6's down. You guys good with that? So I want this as a fraction. So let's do it like this. 120 times 0.25 is 30. Ew. We can convert that, 10 over 30. So 10 divided by 30 is 1/3. So K is equal to 1/3. So I'm back to my equation here. B equals 1/3 times A times B. So now I can figure out how many bags I'll need to mulch 200 square feet. To a depth of 4 inches. Oh, so that's 4 inches, 1 foot over 12 inches. I'm pretty sure that is 1/3 feet. So that would be 1/3 times 1/3 times 200. 22.22. Okay, so let's bring it back to the problem. So I need how many bags? Could I buy a 0.2 bag? No. So I need a little bit more than 22, and that would mean I need 23 bags. We'll spread the other 0.78 bags evenly to make a nice